Hey,
Hey,
okay, fine. Did you figure out how to get it to do the YouTube thing?
no, I don't know why. Like, my account is connected to YouTube and everything, but it won't let me. I'll have to talk to the teacher.
You have to do it at Google. It's Hangouts on Air is how you have to do it, just not the regular Hangouts.
Oh, maybe I'll try that next time.
Yeah, I tried to do a Google Hangouts on Air, but I guess invite.
Oh, hmm.
Um, Jenny is trying to call in. Did you start this one or did I start this?
I'm pretty sure you started because I got a notification. It said join call, so.
Okay, then it is recording. And now I just need to figure out how to get Jenny added in. He's trying to call me on another one.
Really?
Yeah, so nice. I sent her a request more than once on this one. So are you currently at,
What?
are you currently like taking classes at BYU?
Yeah.
I think she has joined.
Can you guys hear me now?
Yep.
Yay! Okay. I don't know why today it was giving me fits, but.
Okay. All right. So I guess we'll just go ahead and start. I'll start with number 6.
Okay.
It says the mean score of all GRE scores is 1 through the standard deviation of 8.8. Question A is scores on the qualitative portion of the GE are approximately normally distributed with a mean of 150.8 and a standard deviation of 8.8.
That's what I got. B says, what proportion of the people who take the quantitative portion of the GRE will score above 165? And I put 0.053.
Yep, that's what I got.
Yeah.
Okay.
And then C, if a student's score is the 10th percentile, what would their corresponding z-score be? Negative 1.2816, and it's not unusual.
Right.
Okay. Do we drop it down to 3 decimals on that one?
Yeah.
3
Sure.
after the decimal? Okay.
Yeah, something I read said in this course to leave it at like 3 decimals.
Okay. Just double checking.
So D says, what is the qualitative GRE score for a student who scores in the 10th percentile? I got 139.5.
Me too. Okay. 7 says the mean speed of hydrogen at room temperature is 1800 m's per s with a standard deviation of 600 m's per s. A, at room temperature, the mean speed of hydrogen particles is approximately normal with the population mean of 1800 meters per second and a standard deviation of 600 meters per second. That one's.
Yep.
That's what I got.
Okay.
B, what is the probability that a randomly selected particle has a speed over 2,500 meters per second? Put 0.1216.
Ooh, I didn't get that. So how did you do that one?
So you do the 2,500 minus the 1,800, and then divide that number by 600, and then you get the 1.16, and then you put that into the normal distribution applet thing.
Okay.
Do the
positive
last part of it because it's over 2,500, and that should give you the 0.1216.
Okay, so you lit up the 2 left sides, the middle and the left?
Just the farthest on the right.
Okay, all right. Let me do that real quick and see if I can get it. That would explain. Okay, so my number comes out, and you read the area, is that right?
Yeah.
And what did you get?
0.1216.
Oh, I don't get that. I get 0.0478. I don't know why. So I'm doing something wrong. So just the far right is lit up blue.
So on the bottom, did you put the z-score as 1.16?
No, I put 1.667. That's my problem. That would make a difference. Okay. All right, 1.0.
1.16.
1.16. Okay, 16. Let's see if that helps. That works a lot better. Okay. All right, thank you.
Yeah, no problem.
All right. So then C is what is the probability that a randomly selected particle has a speed that is less than 2,500 meters per second? I got it's 0.8784.
Yep, that's what I got.
And how did you do that?
Subtract 1 from 0.1216.
You subtracted it? Oh, okay. 1.0 and then 1.123? No? What was the?
26.
Say it again.
It's 1 minus 0.1216.
216. Okay. So 0.1216.
Yep.
And where'd you get that number from?
I got it from.
Is that
It's the
answer to B?
Yeah.
Okay.
Well, yeah. Part of the answer to B.
Okay. All right, that helps. All right. D, what is the probability that a randomly selected particle has a speed that is less than 1,500? And with that one, I did the 1,500 minus 1,800 divided by 600, and I got 0.5.
All right.
Oh, negative 0.5. Don't forget the negative. Is that right?
Yeah, and then you have to plug it into the normal distribution applet thing.
Okay, down at the bottom on the Z?
Mm-hmm.
Okay. Oops, got to put it on the negative side. Okay, negative 0.5. Okay, so which part's going to be lit up?
Just the far left.
Okay, that makes sense because it's... Okay. Okay, so then at the top I get 0.3085.
Yep, that's what I got.
And do I round that to 31%? No?
I didn't.
No, I didn't round it to 31.
Okay. Just curious.
All right. So E, what is the probability that a randomly selected particle has a speed that is between 1,500 and 2,500 meters per second? And I got 0.5698.
And tell me how you did it.
So you subtract the probability of less than 2,500, so that's the 0.8784, and then subtract that from the less than 1,500, which is the 0.3085, and then you should get the 0.5698.
Okay, so your first number was 0.874?
8784.
8784. Okay, that's what I was missing, a number there somewhere. Okay, and subtract them. Okay. All right.
Alright, so problem F is, what is the third quartile of the speeds of hydrogen at the room temperature? So you just have to take the numbers you already have and plug them in. So I got x equals 2.204.
Mm-hmm.
Say it again.
X equals 2.204.
And is that the same as E?
No, no, it's a different answer.
Okay. How'd you do it?
The Z equation, you have to take it. So
Okay.
you have the answer for Z, which is 0.6745.
Okay.
And then you have equals, and you don't know what the X is, so you
Okay.
do X minus 1,800.
Okay. And then 600 underneath.
Right.
Okay.
And then you solve for X.
Okay. All right. That makes sense. All right. Is it me?
Mm-hmm.
Okay, 8. Determine whether the data represent in these QQ plots are normally distributed or not. Record your answer for each graph and justify your answer. So plot A, I would say not. Because the straight line, it's all over the place. It's not even close to a straight. from 0.
Alright, so plot B, I said not normal because it looks like there's outliers
Okay, good.
because of the S-curve.
So plot C is normal because you could draw a line through it and the little humps that are in it would still be kind of normal.
Okay, plot D, the same thing. I think you could draw a line through it.
Yeah.
And be pretty straight.
Mm-hmm.
Yeah.
Alright, and then plot E, I said not normal because the downward curve in the beginning suggests that the data is skewed.
Okay.
And plot F is definitely normal.
Yeah.
Okay. Very good. All right.
So now we need to do the quiz.
Okay.
Yep.
I got to pull it up here just a sec. Have you guys had times when you couldn't get on? Oh no, it's not letting me on. During the week, is it times when it won't let you on?
I had it once, but not too bad.
Very often. Okay.
Yeah, mine usually works.
Okay. Okay, so group 5, group meeting, right?
Mm-hmm.
Start. Okay. I think I'm almost there. Okay. So 1 and 2 are easy. Okay. Number 3, it says the total area under the density curve must equal, is it 1?
I think so.
Is it between 0 and 1 or 1?
I think it's just 1, right?
Okay.
I think 1, yeah.
Okay. All right.
Alright, number 4. Under certain circumstances, a density curve can drop below the x-axis. That's false, right?
Right.
False. Good.
A normal density curve is systematic. That's true.
Symmetric?
Symmetric, sorry. Yeah, symmetric.
Okay. Okay. Oop, come on. Using the following image to answer questions 6 and 7. 6 says, which of the following elements of the figure represent the z-zone in the image? And it's the -1 and the +1. Is that right? Oh, we got to go A, B. Ooh. Z-zone. Ooh. C? Go with C? Okay.
Yeah, that's what I think.
All right. Okay.
Alright. Which of the following elements of the figure represents the probability that the z-score will be greater than 1? Not B,
According to the 6895 miles, 99.7 rule, what population of the data from the bell-shaped distribution will be within one standard deviation of the mean?
Oh, within one? Isn't that the 68%?
Yes. 68. So we're not using the picture up above, right?
No.
Okay. Okay, good. All right. Suppose that z-scores come from a standard normal distribution. Use the normal applet to answer this question. What portion of the values from this random variable will be between -1 and 1? Give your answer as a decimal accurate to 3 decimal places. If your answer was da-da-da, you'd record it as 0.389. Okay. So I don't see what data we're supposed to put in there.
Let's see.
Ooh, how about 68%? No? No, that doesn't work.
That's what mine says, the 0.6827.
So what did you plug in there?
So for the z-score, you put 1, and then you just click the middle area. And then it should show the 0.6827, but we have to round it to 3, so 0.683.
Okay. 0.683.
Okay.
In the next one, we would just put 2 in the z-score, right?
What?
Next one, you would put 2 in the z-score?
Yeah. Yeah.
Okay. 0.955, right?
Mm-hmm.
Okay. I'm lost. Let's see. All right, so we got the normal thing, and we...
Yeah, so then for question 10, it says between -2 and 2. So you have to change the z-scores to 2. And then keep
the center?
Yep.
Okay. And I got 0.9545?
Yeah, but then round it to 3 decimals.
Okay.
And then, so for 11, we change it to 3.
Okay.
And then we should get 0.997.
3.997, yep. .997. Okay. Number 12, look carefully at your answers to the last 3 questions. What do you observe?
The values match the 68, 95, 97.7.
Oh, they match.
Yeah.
I agree. Number 2, is A.
All right. So then,
All right, so then, is it my turn? The amount of protein that an individual must consume is different for every person. There are solid...
use this information to answer questions 14 through 17. And then what proportion of the population has a protein requirement that is less than 0.0 60. Okay, just a second. Gotta get my calculator. Okay.
0.07 plus the Q.
And will be less than that. Okay, did you get 0.1957?
How'd you do that?
Okay, so I did the 0.60 minus the mean, which was 0.66, and then you divide that by the standard deviation, which is 0.07.
Okay, what was your X? You faded out.
Oh, sorry, 0.60.
0.60. Okay. So a negative 0.6, negative 0.06.
And then
divide it by.
And then
Okay.
divide it by 0.07.
So our answer is negative.
That gives you 0.857. So then you plug that into the z-score for the applet thing, and then you do just the far left, and that should give you 0.1957.
Okay. I'm a little behind, so let me catch up. All right. So it's a negative, so I'm putting it on the negative side. Right? 57. Okay, and just the far left?
Mm-hmm.
Okay. So 0.1957 and round it?
Yeah, that's what I got.
Six. 0.196. All right. A little behind here.
Mm-hmm.
Okay.
All right, what did you say you got for the z-score? Sorry.
The z-score, I got 0.857.
And that's the negative 0.06 over the negative the regular 0.07 divided?
Mm-hmm.
Okay.
Okay. Yeah.
Double check it so we get them right.
Yeah, that. I came up with the same thing after I did that.
Okay. Just
Okay.
that's good.
All right. So 14 is what portion of the population has a protein required that is more than 0.06. So wouldn't we just select the area that we didn't select before?
The two right ones?
Right.
I think just the far right one, right? Or
Okay. Is it negative or positive? That's 60.
it's positive.
Okay, so it stays the same.
Yeah.
So I think it should be the two right ones? Am I wrong? Sorry. Phone's going off.
I don't know.
So more than 60, right?
Yeah.
And we got a negative 0.857.
Right. So you would actually just take 1 and subtract the 1.196, and that would tell you
Oh, yeah.
what the more population would have.
Okay, say that again.
You take 1 because everything under the curve has to equal 1.
Okay.
So if 0.196% of the population is less than,
Gotcha.
to find what would be more than, you would just subtract 1 from the 0.196.
Okay. Point.
So .804.
Yeah.
804, that's what I got. Okay, so 0.804. And is it positive or negative? It's positive.
Positive, yeah.
Yeah.
Okay, so then,
And that matches what it when I put it in there too, so that's good. Okay.
okay.
All right. Number 15, it says, what proportion of the population have a protein requirement that is less than 0.70? Give your answer as a decimal, accurate to 3 decimal points. So 70 minus 66 is it's a positive this time. Positive 4, so positive 0.4 over 0.07. All right, I'll get there real quick. 0.04 divided by 0.07 equals, I get 0.571.
Mm-hmm.
Okay. And do we plug that in? Now are we doing positive? Less than 70. Okay, so we put it in the right side. 0.571. And then we highlight the 2 left sides?
Just the far left.
Just the far left. And why is that?
Because it should be less than 0.70.
Oh, yeah, the middle number. 0.7. Okay, I got 0.284.
That's what I got.
Yeah.
Okay. Okay, so for this one it says, find the probability that a random selected person will have a protein requirement that is between 0.60 and 0.70. So then we just have to shade the middle or wait. Or take our last one, so the 0.284, and then
Subtract it.
we do the 0.60, like the more than 0.60, which was the 0.08 or 0.804, and then subtract that from the 0.284, and should give us 0.52.
That's what I got.
What'd you get?
0.52.
Oh, shoot, I got 0.42. Oh, hold on. 0.804 minus 0.284 equals, okay, 52. Phew. Okay. Sorry. 0.52. Okay. Okay. And the 35 percentile, that's pretty easy, right? We just put that up in the top for the next one?
I guess, yeah. I guess
But what do we highlight? Oh, everything below.
No, that's not right. And the 35 percentile for protein.
I did negative 0.385. What'd you guys get?
Just a second.
Okay.
Is that all we have to do is just plug it into the area?
I don't know.
I don't either. I'm thinking it's the far left. It has to be blue. To
Oh,
be
yeah.
35%.
I
Does
think
that
that's
sound right?
what we do because I was looking because we did some like this on the homework and it's for the 10th percentile.
Okay.
It shows the answer and it says like they just put the 0.10 on the top. So I'm assuming that's what we do.
We do? Okay. Did you guys get the same answer then?
So then we just put the 35 in the top.
Yeah. 0.35
So then 0.385, is that what you got?
on the bottom?
Yeah.
Yeah.
That's what. And mine's negative. Is yours negative?
Well, there's a positive and a negative. Oh yeah, that's true. I guess we have
35 would be the left, right?
Yeah.
Okay. Do we all agree on that?
Yeah.
Yeah.
It almost seems too easy, so I'm worried.
I know.
All right. So the next one we do 0.8 on the top.
Yeah.
And okay, now it highlights two parts.
I think it would still be negative though, right?
I'm thinking 80 would be more than half.
Yes. Remember on question for like the classwork or whatever for part 2,
Okay.
where on F, where you had to go at it backwards? Is that not what this is? I could be totally wrong. I'm totally asking here.
Okay. Say it one more time.
On question F,
F. Okay.
how we have to go at it backwards? Is that not what this is as well? I could be wrong.
Oh, because that's the quartile.
Right, but that would be the third quartile is the 75th%, right?
Oh, that's what the 75.
I mean, I could be wrong.
The third quartile is 75%. So it should be positive. I've got the answer open. So I don't know.
Okay, so it's going to be positive then.
Yeah. The 0.842 positive. Yeah.
Okay. That makes sense.
Does that seem okay?
Yeah.
Okay, so submit.
Yeah.
Oh, wait a minute. No, I haven't. Hold, wait.
Oh, I already submitted it.
Oh, I'm sorry. Okay, what was the answer for the last two?
What? It was negative 0.385 and then 0.842.
And they're wrong.
Yeah.
Shoot. Oh, so we got to figure this out. Shoot. Okay.
That's what it is. I think we need to go at it. We should have gone at it backwards like we did with F.
Okay.
But the problem is it doesn't give you what the right answer is.
Yeah. Shoot. So 80 should be passed between the 1 and the 2. Because 2 is 95 and number 1 is 68. So yeah, 68. So that we know we were wrong. Shoot. Oh well. So how should we have done it? Explain F again.
So we use the equation
to search for X.
Yeah.
The equation, or not the X, but the
I see.
whatever that equation is.
Yeah, that one. Let me see. See if I gave it a name. Nope, I didn't give it a name. Okay. Okay. Well, still, 85 is not bad.
No?
Yeah.
Pretty bad.
It's true.
I'm going to study it a little more, though. Whew. So really, just the end. What all did we get wrong? Woohoo! Just at the end. So I'm going to study that more. 15 we got wrong. Okay. 17. Uh-huh. So that was just too easy. 17 and 18.
Yeah.
Should have known.
All right. All right. I will post this. Maybe I did it right. I don't know.
It seemed
Hopefully.
different, so I hope so. Perfect.
I guess we'll see.
Okay.
All right. We'll see you guys on Monday.
All right. See you later.
All right.
Yeah.